Hi, everybody. Welcome to our holiday edition of the New York JavaSIG, our December 2024 meeting. So thank you all for coming here, and thanks you all at the internet land. This meeting is sponsored by our host, BNY Mellon. So thank you, BNY Mellon, again for hosting us. Special thanks to Oracle for sponsoring the pizza. So thank you, Oracle. That veggie pie was very good. And of course, JetBrains with our IntelliJ. I think we can't call it a raffle anymore, so I think everybody has a license. Who does not have an IntelliJ license? Okay, so 3. So we already know the winners of the raffle. So tonight we have 2.2 speakers tonight. So we have Sean Sullivan talking about Amazon S3 and Java, and then Andrus is going to talk about Bootique, a really cool app platform. But before that, I was going to do a short lightning talk. Since there were a lot of announcements about AI this past week. It's probably the most powerful, big announcements in AI over the past week with OpenAI, and then Google, jousting with them back and forth. It's super powerful. I mean, these are taking AI to like the next level. But I'm not going to talk about that. I wanted to just talk about just a quick ChatGPT, a couple of tips, 2 tips, and then I'll get off and turn everything over to Sean. So the best way to do this is to get out of PowerPoint, or pardon me, PowerPoint slides, and something that I often do and need is you have an image and you need to scale it. I mean, either you have a photograph and for a conference, they say like, we need a high resolution picture. I don't have one because this one's, we can't blow it up. You look pixelated. Or I need the JavaSIG logo for a conference, but it's like too small, this, that. So just want all of you to understand that most LLMs, and of course, OpenAI's ChatGPT has this capability as well as others. But let's say I have the JavaSIG logo, which it's tiny, right? And I need it scaled up. So let me just drop that into ChatGPT. And in the interest of time, since I only have now 4 minutes, let me copy that. Where's that? Where's that? And if you can you all read that? So I want to scale the image 4 times. I just picked 4 times. It could have been 5 times, 3 times. Increase the resolution. Don't change the colors. Increase the resolution. Smooth the text. So that's a simple prompt. And hopefully, I know OpenAI announced their Sora video tool, which, I mean, millions of people are using that video tool. So their servers are being hit really hard right now. So this normally takes a few seconds, but it might take a little bit longer. Yeah, I'm sure. I mean, I could have brought up Bash and did it from the command line, right? So it's a lot easier doing it this way because I always forget the options. I've got, let me man this page, right? So I mean, this is like an average person can do this. I mean, you don't have to be like a command line person, and that's pretty cool, right? So it can understand how to do to change resolutions of images. So that's one cool tip. Another one, and well, actually, there's 3 tips. Well, here's another tip. So you're inside of ChatGPT or Anthropic, Claude, or Google, and you have context in there. And after a while, the context gets polluted, right? You're not getting what you want because the context has too much stuff in it that doesn't understand. Like you're talking to 2 people and you forget what you talked about. The context is polluted. So the way that you clear that, you say clear context. Oh yeah, wow, that's a good tip. So now and it should say, yeah, okay, now context. Now it's basically the buffer was clear. So now you can start. You don't have to bring them another tab with ChatGPT. So that's tip number 2. Let me see, what's another one? So I recently gave a a course to an Italian company, and I don't speak Italian, unfortunately. It was Foundations of AI, just like my LinkedIn course. It's Foundations of AI and ML for Java developers. It's a couple-day course, and there were reviews, and I asked for the reviews because I want to see how I can improve my course. Right? Where are the reviews? And so they sent me some of them, and the Italians, being the Italians, just gave me images. They didn't give me text, right? They didn't even give me PDF. They just gave me images. And I don't want to argue with the Italian companies because they're unique. They're unique. So I got things like this. So here's a review, and it's like standard kind of. Here's the name of the company, Technology Transfer. I changed the name of the person because of course they have GDPR laws, so that's a fictitious person. But this is not a fictitious review. This is a review for my course. So of course I picked a good one. So it's all in Italian. So let me drag this into here. And since I have 2 minutes left, let me do this. So what I said is that summarize that for me. Summarize that Italian image, and it uses strong positive language because I could use all the help I can get. Read this stuff. You give me the top 5 comments in JSON and using English because I can't read Italian, right? And extract the ratings in this fashion. And I said, well, excellent is 4, and I'm guessing that buono is good and sufficient is 2 and insufficient is 1. So that's my prompt. Yeah, let's go down here. And I have to put a quarter into the OpenAI meter to get it to go there. 1 minute to go. Yeah, after Sora was announced, their servers are hammered. Yeah, like exactly. Okay, let me retry. There's one thing about AI, you get different results every time. So how do you test this stuff? Okay, so here it is. Here's a summary. And this is pretty easy. I mean, it's pretty cool that I'm doing this from the web app. You can imagine if you wrote a Java program that called this, and you could do it for thousands of reviews for courses, and it could give you a summary, and then you say, well, now summarize the summaries, right? And here are here's JSON, here are the comments, and I'm missing something. So I asked for, oh, here it is, right here. It's right in front of me. So here's a JSON, which of course is not exactly sophisticated, but it's in JSON. And now if it had other fields, it would extract it for me. So I can put that, and I said, insert that, give me the SQL to insert a database. That's pretty cool, right? That's pretty cool for us. So, and I made it with 10 seconds ago. So thank you. So let me turn everything over to Sean.
Well, yeah, hold on. How did you figure out that clear context? Is it there on their documentation website, or is it
How did it
a clear context?
clear context?
Is it mentioned somewhere on OpenAI?
So they have
Like, is it a
they have a forum.
Okay.
They have a forum, and if you're nice to some of the engineers, they tell you certain things.
Okay.
Like when I asked, like, what exactly does a system prompt does? And I got a very detailed answer what exactly a system prompt does. So, and I said, well, how do you clear the context? With respect to like, clear context was the answer.
System context or the whole context?
The whole context.
Whole context.
Yeah, yeah.
Okay.
Thank you.
All right. So my name is Sean. A longtime Java developer. Been doing it for more than 20 years. I've been pretty active in Portland, Oregon. I'm a co-organizer with the Portland Java user group. Tonight we're going to talk about Amazon S3, and we'll kind of have a Java focus to the presentation. We'll talk about like things that Java developers need to know when using S3. We'll move on from there. So I like to think of myself as a developer that builds my own tools or sometimes uses tools provided by AWS. And that's sort of the theme of the talk is, how can you effectively use AWS tools to use S3 more effectively? So I think many of you might know that last week was the AWS reInvent conference in Las Vegas. Anyone attend the reInvent last week? Yeah, so Amazon likes to release a lot of their new products and service offerings at reInvent, and that was especially true last week. There were multiple announcements about S3. So we'll kind of like highlight at least two of the big announcements about S3, and then I'll cover some other topics along the way. So
yeah, your videos.
Alrighty. So there were two big announcements last week at the reInvent conference. S3 tables is a new capability that's now ready for use. And then S3 metadata was another release that's available as a preview. So you're probably wondering, what is S3 tables? Kind of a new way to use Iceberg. And Iceberg is a table format. It's a way for companies to manage big data and analytics. So if you had petabytes of information, you might be looking at technologies like Iceberg as a table format or Delta Lake. But this announcement last week was significant. It indicated that Amazon is really doubling down on Iceberg as a table format. So S3 tables is the name of the feature. And if you're familiar with S3, you know that you save data into buckets. And so what they announced last week was there's a brand new bucket type called table buckets. And data that gets persisted into a table bucket will be exposed as an Iceberg table. And what's really significant about it is that Iceberg tables are now treated as a first-class resource. And that means you can have access control policies associated with your Iceberg tables. So particularly in an enterprise environment, you may have tables that you want to expose to different query engines. And you may want to set up different access controls around that. So you can now define different policies for different tables. The other thing they released last week was a Java library for S3 tables. It's called S3 Tables Catalog. It's on GitHub. They've also published one version is now available in Maven Central. And so, if you're looking to use S3 tables, you include this library into your Java project. And what this gives you is a Java class called the S3 Table Catalog. And the table catalog is an implementation of the Iceberg catalog interface. So it's kind of a new way to use Iceberg within the AWS environment. So it's a pretty significant announcement. The other big announcement was this thing called S3 metadata. And S3 metadata is a way to capture system-generated metadata about your S3 objects. So it gives you some system attributes that are automatically generated, but you can also add custom metadata as well. And what's cool about this is that all this metadata gets published as Iceberg tables, which then means you can use whatever your favorite Iceberg compatible query engine to write queries to retrieve things from the Iceberg tables. So this is a common use case where companies will be persisting, individual files into a bucket, S3 bucket, and then they'll have like maybe a separate data store for metadata, but you no longer need to have like a separate data store. You can now have these metadata attributes sort of integrated into your S3 storage. And you can write, because it's in Iceberg tables, you can write SQL queries to look at the metadata. So that's brand new. But the history of S3 was that it actually came out in 2006, originally known as the Simple Storage Service. It's no longer simple. They don't really call it simple storage anymore. It's just S3. Fundamentally, it's just a way to persist data in the cloud through a REST API. And this is one of the earliest APIs that AWS rolled out. And under the covers, like the internals behind the scenes, Amazon is managing like a storage fleet. So they have, fleets of hard drives across many availability zones, and they are responsible for managing the health of the storage fleet. And that's kind of like the magic under the covers, is that you are entrusting the data into their system, and then they are doing checksums and they are doing audits to ensure that your data is always available. So for example, if a hard drive became unhealthy in their system, they would detect it and do repair work. And that's all transparent to you, the Java developer. So the basic concepts are buckets and objects. A bucket is a container where you want to store files. And typically, at a large enterprise, you can provision more than one bucket. It's kind of up to you as a developer to think about how do you want to organize your data. Which buckets do you want to have in your enterprise? And if you're provisioning a new bucket, you need to really think about what type of bucket you have. So in the beginning, S3 only had one type, which was the general purpose buckets, which was the default. But in the last year, they've added 2 extra bucket types. So a year ago at reInvent, or I guess more than a year ago, directory buckets became a new thing. Anyone using directory buckets today? So directory buckets is it's a bucket type that they created to support S3 Express one zone. And S3 Express one zone is it's basically a way to use S3 in a really high performance way. When you say that you want to have a directory bucket as an Express one zone storage class, you're basically saying that you want really high performance, but the data will only be saved in one availability zone, which basically means it has lower durability guarantees. So for use cases where you truly need like maximal performance, but you don't care about like the durability guarantees, directory buckets are kind of the way you go about that. And then the third option is just what was announced last week. So that's the Iceberg tables. And one sort of caveat, and this is sort of a weird thing about AWS. So bucket names are globally unique. And this is weird because in most AWS resources, you're provisioning a resource that's just sort of scoped to your AWS account. But S3 bucket names are not like that. In fact, if I create a bucket called Sean, that is part of the global namespace of S3. And if there's another Sean in the room and he wants to provision a Sean bucket, well, I might have already allocated it. And we may have different AWS accounts, but that's not how it works. I've already allocated Sean for myself, and no one else can get it. And so this is sort of a weird quirk about S3, and it's very different from other AWS cloud services. And I put a little warning icon on here because what can happen is if I provision a bucket called Sean, my application is reading and writing to the Sean bucket, and then maybe 6 months from now I decide I'm going to delete the Sean bucket. Well, there could be another Sean in the room who notices that the Sean bucket is unreserved, and then they create a bucket called Sean. Well, now it's owned by someone else. And so that's sort of a weird concept, that after I delete it, I no longer have rights to that name. I've basically lost rights. Someone else could create a bucket with the name. If my application inadvertently was still referencing that bucket, then I'm accidentally maybe trying to access a resource that's in another AWS account. So something to think about in that regard. So with S3, you're paying for the data that you're storing, and the amount that you're charged is sort of based on how much data you have and the storage class. And so this notion of storage classes is pretty important. There's different guarantees about the performance of S3 based on the storage class. And by default, the default storage class is called standard, but there's many different flavors of storage classes. Intelligent tiering is kind of a popular option. It's basically a way to save some money, where you can designate that some files are classified as intelligent tiering, and that means that basically Amazon will keep track of your access patterns on those files. And if you haven't accessed a file in 90 days, then they realize, oh, you're not actively using it, so we'll put it in a lower cost storage class. And so you'll have slower access times, but if it's data that you haven't really read in 90 days, then most likely you probably want to save money by moving it to a lower tier storage class. And then Express One Zone, that's what I mentioned, that was launched last year, and that's really for high performance access. But it's single availability zone. And so Amazon frequently talks about storage class choices, and this is from reInvent a year ago. And they basically said they give you all these options, and then you need to think about your use case and decide whether is your data going to be frequently accessed, or is it going to be accessed infrequently? So an infrequent file might be something I want to archive. Maybe it's maybe I have health records from 10 years ago, and maybe probably not going to retrieve it very much. So maybe certain kinds of data will be more amenable to storage classes that are less expensive. And Glacier is, Glacier Deep Archive is the option on the right. And that's for things that you wouldn't typically read very frequently. And it kind of gives you the lowest performance. Now, what's interesting is that S3 exposes an API, a REST API, and Amazon publishes a REST specification as a PDF file that documents all the API calls, all the request headers, all the response headers, all the error codes, things like that. And this originally was called the Simple Storage Service, but the PDF specification actually is 3,300 pages. And what's funny about this is about 3 months ago, this file was much smaller 3 months ago. I have 2 copies of this file on my computer. 3 months ago, the file was 1,900 pages, and they recently updated it, so it's over 3,000 pages. So it turns out this is a really hard document to read. As a developer, I'm not going to read through a 3,000-page PDF. And this is where SDKs really become valuable. So the Java SDK is how you're going to interface with S3. you're not really going to read this spec. But the spec is pretty comprehensive, describes all the different operation types in S3. Typically, you're either uploading objects, downloading objects, or getting a list of things that are in your bucket. And so for Java developers like us, the real way that people build things is with an SDK. So there's an older SDK called V1 SDK. The V1 SDK is, I don't know, more than 10 years old at this point. And if you're starting a new project today, don't use V1, go to V2. You also have the option to use a Kotlin SDK, and that has a separate different artifacts in Maven for that. And the reason you don't want to use the V1 SDK is that Amazon announced the end of life for it. And so 12 months from now, there will be no further support for the V1 SDK. I was talking with my coworkers about this recently. I said, do we have any code in production that uses the V1 SDK? And the answer was yes. Like, yeah, sure. If your company's been in business for more than 10 years, you probably have some apps using the old SDK. So you've got the clock is ticking. You got a year to try to clean that up. Anyway, but the SDKs are all open source. You can find them on GitHub. You can file bug reports on GitHub. You can contribute code on GitHub. So they do a good job of actively updating these projects. The V2 SDK is updated almost every day. They put out a new release. So as the AWS cloud platform evolves, they're releasing changes to the cloud, and then they're updating the SDK almost within the same day that new things roll out. So for a Java developer, this is how you would set up your Maven POM. There's a bill of materials file, set the version number, and do a scope import. And that's typically how I configure projects that I'm working on. And then after you set up the bill of materials, then you have to specify the dependency for which Amazon service you're accessing. So here, you want to use S3, you add this dependency to your project. But that's not all. It turns out that this SDK is designed to interface with a variety of HTTP clients. This is like the transport that's sending the request to Amazon. So if you want to send in a request to S3, it has to go through some HTTP layer. And they designed it to be pluggable. And they provide implementations of their pluggable interface. So you can use the Apache HTTP client. You can use Netty as your client. But the new recommendation from Amazon is to use the CRT client. And you're probably wondering, what is CRT? CRT is common runtime. It's basically some common libraries that Amazon built internally. They've made it open source, and now they're kind of recommending that application developers start using CRT to interface, to bridge the SDK to the cloud. So if you're a Java developer, you'd want to include the CRT client library to your application path. And in fact, they were talking about, just last week, there was one of the tech talks at reInvent was about S3 performance. And this slide is from their S3 performance presentation. They explicitly said, if you want to get maximum performance in your application with S3, make sure you enable the common runtime. So as a Java developer, you've got different options about how you use the API. They provide an asynchronous API and a synchronous API. And so for S3, you're either going to use S3 async client or S3 client. The async client, like basically every method call returns like a completable feature, basically. And very common pattern for modern SDKs these days. So go ahead. Oh.
Yes.
So under the covers, are they using the same the same REST API, or is it different?
Yeah, under the covers, it's the same REST API. Yes. So in terms of provisioning buckets, provisioning buckets is something you might do once. You provision a bucket, and then you're not like adding buckets every single day. So you as a developer need to think about, what was your strategy for provisioning buckets? Some people have infrastructure as code. Other people just log into the AWS console and just click in the web app, and you can say create bucket there. Infrastructure code is kind of like the more preferred approach, whether you're using CloudFormation or something else. So if you look at the CloudFormation docs, yeah, sure enough, there's a resource named bucket. You could write a CloudFormation YAML file that defines your bucket and its attributes. And if you're not using CloudFormation, there's other more modern alternatives. Pulumi is increasingly popular. Pulumi is a company out in Seattle. So they give you like an SDK to provision these resources. So this summer, I had a lot of free time, and I was doing some hacking, and I wrote this little GitHub project that I called the S3 Playground. It's just a place for me to like experiment with different aspects of the S3 SDK. And so what I was doing with my code was I was trying to like write a test suite that would evaluate the synchronous client and the asynchronous client for S3. And I also wanted to test it against AWS, as well as other competitors who offer a compatible API. So when I said that there was an API specification that's 3,000 pages, well, there's competitors of Amazon that are trying to implement the API, and then they offer you a commercial version. They advertise it as S3 compatible. And so I wrote some code. I was like, I wonder how compatible they are. And so I've done like some simple testing with Wasabi. That's a company in Boston. They do S3 compatible storage. Tigris is also S3 compatible. They're out in California. And there's a variety of others. In fact, Google Cloud Storage has an S3 API. It's not like the default API, but if you wanted to just use S3, you could use the S3 SDK from Amazon, and you could talk to Google Cloud Service through the API. All you need to do is set the right endpoint, and that actually works. So for some applications, you might want to just test locally on your laptop, and you could use test containers to do that. Anyone using test containers for like Postgres or Redis, those sorts of things? Yeah, so test containers can also run a local implementation of S3. It's really sort of an emulated S3 that runs on your laptop. There's 3 different options that are really popular: Local Stack, MinIO, and Adobe S3 Mock. I've used all 3. I was testing all 3 of them. They all seem to work pretty well. If I had to pick a favorite today, I'd probably say MinIO. Seems to have pretty good momentum behind it, but all three are pretty popular. So MinIO is for S3. S3 Mock from Adobe is for S3. Local Stack does more than S3. Yeah.
I'm using local stack and does more than S3. That's why I'm asking, like, if the other guys are also emulating other services.
Yeah, Local Stack is a more comprehensive solution. It does like DynamoDB, it does SQS, a few others. So this is like an example. I was running a little test suite that I wrote, basically JUnit 5, ran a bunch of tests against MinIO. I was testing the Netty client, the CRT client, and the Apache client. The test passed, I guess. It seems to work. But again, if you're testing against MinIO, that doesn't guarantee that your code's going to work against real cloud. So, you never really know until you deploy to prod. basically. So from a programmer's perspective, when you're using the SDK, there's a class called putObjectRequest. That's how you upload data. GetObjectRequest, that's how you retrieve things out of AWS. You also have the ability to do multi-part uploads. And this is interesting. Like, say you had like a 10 gigabyte file. You might want to break up that 10 gigs into smaller parts. And then the way you would do that, you orchestrate it in your application with this multi-part request. But it turns out like that's not the only way to upload large data. There's also the SDK gives you this thing called the transfer manager. So if you had like many files and they're all like 100 gigs and like don't want to write all the code yourself about managing the upload and the transfer status, the transfer manager helps you upload multi-part files. And it also gives you a listener interface. So you can register for events if you want to know about the progress of your uploads. And that's particularly useful if you're like building a GUI and you want to like show the user the progress of the transfer. So there's callbacks to do that. So the other big use case around S3 is people are now using it for big data analytics. This is almost like the default thing people do these days. And some of the pioneering work behind this was from Netflix. Back in like 2017, 2018 timeframe, Netflix was trying to figure out how to deal with petabytes of data. And they ended up inventing Iceberg as an internal solution just to solve Netflix analytics problems. And originally, Iceberg was built solely to run on S3. And then eventually, Netflix realized it was a super valuable technology. They ended up open sourcing it on GitHub. It was originally on github.com/Netflix. But then very soon after that, the code got donated from Netflix to the Apache Software Foundation. So now Iceberg is known as Apache Iceberg. And now you have multiple companies contributing to this. So Iceberg is a table format. It's a way to manage both data and metadata. And all of that gets stored into S3 buckets. An S3 table, well, a table that lives in an S3 bucket is what I should say. So there was a book that came out this year. I think it was back in May. This was like a new release. I think some of the folks from Dremio ended up authoring this book. But it really describes sort of like the history and the motivation of why this table format exists. And the basic idea is, you know, S3 is a relatively cheap way to store data. And so if you've got petabytes of data, why not choose a technology that's relatively cheap for storage? So a year ago at reInvent, this was last December, one of the co-creators of Iceberg is Ryan Blue, and he gave a talk about the origins of it. But you know, they were trying to fix some issues that they were having with Hive, like the Hive Metastore and so forth. And so they designed Iceberg to address some of the shortcomings that they were having at scale. But Iceberg allows you to, like, you know, you have a well-defined schema, and it has mechanisms for evolving the schema over time. If you're really interested in like the history of Iceberg, I'd go find this on YouTube. And this is one of the slides from Ryan's presentation. But you know, Iceberg is the abstraction. So if you're building big data apps, you can sort of maybe ignore S3, but think about like Iceberg as your primary like interface to your data. And then there was another presentation 12 months ago. This is Netflix talking about how they migrated their data into the Iceberg format because they had a lot of data and they needed to get everything consolidated into Iceberg. And this kind of talks about that journey. And one of the highlights or lowlights of their migration was that they were encountering a problem. You'll see this in almost every Iceberg tech talk in the world. They'll talk about the small file problem, and that's where like, oh, your system has too many small files in S3, and so that ends up sort of being a performance bottleneck. And so there's different solutions out there for addressing this. In Netflix Tech Talk, they talked about how they built a tool called AutoTune that does table maintenance of Iceberg tables. But these days, there's other solutions out there for table maintenance. And in fact, at reInvent last week, that was one of the themes of the S3 table announcement. When Amazon announced S3 tables last week, they said, hey, you know, we know that table maintenance is a burden, so we'll just like try to make it as automated as possible. So there's code, Java code out on GitHub. So if you're interested in contributing to Iceberg, this is like the main project for Java applications. I was able to get something merged into this project like a month or two ago. I was trying to, I wanted to change the way that they were testing Iceberg. So they have a test suite for Iceberg, and their test suite was using two different test containers. They were spinning up a test container with S3 mock, and they were spinning up another test container with Minio. It didn't really make a lot of sense that they were instantiating two different test containers. And so I kind of realized, oh, I can sort of simplify this. So I removed the Adobe S3 mock code out of the library. And now everything just runs in, for a local integration test, everything runs in test containers Minio. So there have been some other big announcements this year. Conditional writes is a new feature that came out in August. It's just a more sophisticated way to write data into S3. There's a couple of blog posts out there on the internet about this. In fact, some of Amazon's competitors have blogged about conditional writes because some of their competitors had this feature earlier than Amazon. So like Minio had this kind of capability before AWS rolled it out. Anyway, so you can configure bucket permissions. By default, resources are private. Kind of makes sense. Secure by default. Don't let anyone read your data unless they need it. Another big concern is performance. I'll just skip through here, but it turns out there are sort of like, they do some rate limiting. And so, you know, if you're throwing a large volume of requests at S3, it may start to throttle you. And I'll just skip down here. So one of the ways you know you're being throttled is you'll see an error code returned, an HTTP status code of 503, and they call it the slowdown code, and that the slowdown status, and that's basically Amazon saying, hey, we're trying to scale up, but we're not quite ready for the volume that you're asking for. So we'll keep trying to scale up, but like, could you please like back off and try again? And so you may see this. There's a couple articles in the user guide that kind of talk about this behavior. Anyway, I'm going to skip through this because I know we're short on time. So I'll just close out by saying last month there was a really good presentation at KubeCon. This is from Justin Cormack. He's the CTO at Docker, and he talked about object storage as a general concept, and then he talked about all the different use cases that people are now the way people are applying object storage in their applications. You can imagine at Docker, they probably store a lot of objects on Docker Hub. Imagine that. And so object storage tends to be very important to Docker. So this is a really good tech talk. Highly recommend it if you're wanting to learn more. And then reInvent has published their videos, which are available on YouTube. And if there's like 500 videos from last week, this is the one that I recommend. This is about an hour long, just very specific about what's new with S3. And it's way more in depth than anything I've talked about today. Definitely worth a watch. I've watched it twice already. It's quite good. So that's really the end. I know we're short on time, so I'll just close here. And thanks for coming.
While we get Andrew set up here. Any questions at all?
Well, okay, so I guess I'm getting into Zoom now. I should share my screen, right? For
your slides or whatever,
this. Oh, okay. So,
whatever you want to show us.
yeah, I guess the entire thing. Desktop. Oh, okay. Never use Zoom on this account. That's already settled. I don't know what's complaining about. Okay. Okay.
Right, and you see where you have, may I?
Yeah, sure. Yeah, if you can get rid of all the Zoom stuff. Yeah.
There we go.
Okay.
Not remove all the Zoom, but remove most of this. There. Oh, that's not good.
Yeah, just
That-
put it in
that's-
the corner.
that-
Yeah. All right. Hmm. Okay, one last check of the resolution. Okay, I think that's the right one. Okay. Hello, everybody. My name is Andrus. I've already done this introduction many times in this Java user group. So I'm probably going to skip a bunch of things. But tonight we're going to talk about Bootique, and Bootique is a faster, simpler Java platform, and there will be some comparisons with a few more popular ones. Okay, promise to skip the introduction, but I still want to mention a couple of things here. So yeah, I program in Java a lot. I work on these open source projects here, and I'm not going to introduce every one of them, but let me just mention that one of them, DFLib, is used to render this heat map that I use instead of the normal green tiles that you would get from GitHub. So that's data from GitHub. It's the same data that is used to render the green tiles there for activity, but it's rendered via DFLib, via DataFrames and Apache charts. So that's just wanted to mention something cool there. But let's actually talk about Bootique. Okay, so about a year ago, I think it was in this Java user group, there was a talk that kind of intrigued me a little bit. It was a talk about how to make Spring Boot applications launch faster. And of course, the talk itself wasn't about Spring Boot at all. It was from a third-party vendor from Azul, and they were talking about their tool called Crack, which is actually a pretty amazing technology. It captures the state of a running application, and then when you're started, it can restore the state right away pretty quickly. And but I was amazed how it was marketed sort of based on an assumption that Spring Boot applications are slow to start. So essentially, they were solving a problem for you. So this is where this was also my premise when we originally started Bootique. So back in around like end of 2015, so almost 9 years ago, I was working with a client. It is still one of my biggest clients, and we were thinking about a new Java platform, just migrating from containers, from wars, from all this sort of traditional old legacy Java deployments, and switching to runnable jars. I will not talk much about why that was needed. I guess we already know that that's sort of a more flexible way of running your Java applications. The whole thing about where's my main method? Can I actually have access to my main method in my application? It was actually a big thing. It is still, but right now we kind of take it for granted. So what we did, we evaluated a bunch of things that were on the market back then, and the first thing we looked at was a technology called Drop Wizard. I don't know how many of you have heard about it. Yay, here we go. I actually know some fun companies that are using it in production to this day, and they're enjoying it. So, but it was a great technology. We actually liked it, but it was very, very I would say like narrow and opinionated. So it was an engine to run web services, essentially REST services specifically, and your Java application can be anything. It can be a headless job that just does something in the background. So we were like, okay, so we like the idea, but we need something more generic, more broad. And then of course inevitably we came to Spring Boot, and I will be doing lots of comparisons with Spring Boot tonight. So I just want to make a disclaimer from the beginning, like where I'm saying something is wrong there or whatever. Like I really respect the team there. They're great people, and of course they're doing something right, I guess, considering the market share of Spring Boot and the mind share of Spring Boot essentially in the market. But the rest of the talk, there will be like maybe some unflattering comparisons and stuff like that. But that's purely in technical terms. So the second thing that we tried was actually SpringBoot, and we did some demos. We did some proof of concept applications, and what we found is this. So essentially, there were like surprises everywhere. So SpringBoot redefined so many like basic assumptions for me as a Java programmer that it was just pretty much unbearable. And I think all these things that I'm listing, it didn't change much because it's actually by design. It was how that environment operates. I mean, this is how it was created. So I'm listing like a bunch of things under the word magic. And this is from a perspective of a person who've never seen SpringBoot, never watched a video, and just like, okay, so I'm a Java developer, how do I use SpringBoot? And so the first thing that of course everybody notices is that there's magic in the code. So instead of just working with objects, in many cases you work with annotations, where annotation just stands for something big and hidden, and something that you may not understand, and you can't even trace it directly because annotation is not really tied to the code. Annotation is just like a promise that something will happen when you put your application in some environment, and then it will be processed and something will happen. So you can't just navigate the code from annotation that executes it. So this was just the general approach, and so we were like, okay, so let's move on and let's keep trying it. And the second thing we ran into, it was class path magic. So a SpringBoot core would activate things that you don't even know that they were there when you add like third-party jars that are not SpringBoot jars to class paths. So essentially, there are hidden features that are activated by something getting on a class path. And the first thing that we found, we were trying to write a migrations application, like a little command line application that synchronizes your database state with your code state. And we added Liquibase to class path, and turns out SpringBoot already had some Liquibase code just hidden there, like sleeping there. It was like a sleeper cell essentially in your application, and suddenly it got active, and it circumvented what we were trying to do with Liquibase. Of course, once you know it once, you stumble through this, and then you can probably use what they're doing. But this was a big surprise. And this is probably where I was kind of like, okay, so maybe that's not going to work for us. So build magic, it's another thing that I noticed a little later, is about SpringBoot dependency management. So it was kind of weird. Like I was writing some tutorial like at a later time based on SpringBoot, and I was like, okay, so I don't want to read a book of SpringBoot or watch a video. I just kind of include a starter in my application, and I get all the dependencies, and here's my app. Turns out that if I just include a starter in my application, all the transitive dependencies that come from the starter, even the Spring itself, like kind of the Spring library, they were all of their own version, essentially. So the versions were like absolutely random, and I couldn't think of why that is. So essentially, I assumed it's a bug, and I opened the bug report with them. And the team is really like, honestly, they're very nice, and like they explained to me, so you need to switch to SpringBoot dependency management, and then all your versions will be fixed. So essentially, you have a tree of dependencies. The dependencies are correct, but the versions are wrong. And this was really something that broke all my assumptions about how dependency management should work in a POM, or if you're using Gradle, it doesn't really matter. The next one is configuration magic. I mean, this one, I think it's kind of the least of a problem for me. But the fact that you have so many ways where you can pass configuration to different parts of your application, and there's like abstractions on top of abstractions, so you essentially you can like substitute things in configurations by variables and all that. So it was kind of just hard to keep a mental model of your configuration of your application. And so this wasn't a deal breaker, but it was just a little bit made us a little uncomfortable. And yes, on top of all that, it was slow startups, and of course, right now, even though Moore's law is no longer kind of a thing, computers are still getting faster. So it got a little better. Like I'm rerunning I will show some numbers at the end of the presentation, but essentially, like back then, it was completely unbearable. Now it's just, I guess, annoying. So essentially, we arrived here. We were like, okay, so everybody everywhere is using that. Why are we so special? Why is, like, it's not clicking with us? Like, there has to be something wrong with us. Of course, you know where this is going. So this is how Boutique was born. So we were like, okay, so analyzing all the shortcomings, we were like, okay, so we can create something that doesn't have the shortcomings. And so this presentation is about, like, where we got with that. And now is demo time. Okay. So I have a very simple project. Is it too small, or should I switch to the presentation mode, maybe? Okay. So, okay. It's been a while since I used presentation mode. Here in yep, presentation mode. Yeah, okay. So yeah, I don't on this class, but okay, I want to show the POM. Okay, so I have a skeleton project. It's really empty. It has a POM and nothing else really. I also have dependency management. It includes Boutique BOM with all the modules. The difference with Spring dependency management is that this is entirely optional. It's just a convenience. All the versions of all the modules inside the BOM is the same versions that we are seeing here. So it's 3.0 M6. So let me actually add a real dependency based on that BOM. And the first dependency is going to be Boutique itself. So we have a bunch of modules, and the shortest one is Boutique. So that's the core. I'm going to refresh it here and create our main class. Okay, so do we need an annotation to run an application? I mean, hopefully not. So the simplest thing, how we can implement the main method, is actually delegated to Boutique, and we're trying to make everything in the framework, trying to make it discoverable. So essentially, once you understand like a few basic concepts, and we're trying not to overload it, so just all the, we want to have a minimum number of abstractions, and once you kind of like get the main things, it's kind of easy to navigate from kind of first principles to what you need to do. So here we are starting a Boutique application. So the first, the logical thing is that we go to a class called Boutique and then see what's in there. And there's a method called main. And this will actually work. So this is all you need to implement your own main. But I'm going to expand it a little bit. I'm going to copy it from Boutique here into our own application. And this gives us a couple of things. So this, first of all, it gives us an idea of how the startup works, and also it gives us a way to customize things here. So we can add more modules. We can add different things here. So essentially, here you start an app, pass the arguments, because the app will be driven by these arguments. So whatever it does, it's driven by the command line arguments. We're doing autoload modules. Modules is one of the basic concepts in Boutique, and they're very simple. They're not like OSGI modules or anything, so they're very easy. And then we execute it, and execution just happens, based on what's passed in here, and then we exit. So why do we need exit? Because we want to pass the exit code, to the shell. So if there was an error or whatever, so it's like we're good shell citizens, so we would like to pass the proper exit code. We can already run this, so there's no logic, but there's just this Boutique shell really. And see what we got. So we already got, each Boutique application has built-in help. So on the command line, a Boutique application is really easy to understand what's in it. So it helps you to understand what it does. It helps your DevOps to understand what it does. And this is just one example. There will be more things that we can check. And by default, Boutique application takes a configuration file, can take a configuration file optionally, prints this help message. And there's also this other help that shows other things. We're going to return to this in a moment. Okay, so let's actually do something to it so that it can perform some useful operation. Let's, for instance, write a REST service. Bootique itself tries to avoid implementing the actual framework. Like, for instance, we don't implement a web server, or like we implement a couple other things, like a job engine, for instance, but where we couldn't find a good fit. But usually we just find a good framework on the market that is solid, that actually makes sense, and we integrate it into. We provide an integration module for this technology. For REST services, we're using Java EE or Jakarta EE, I guess. These days, technology called Jersey, JAX-RS. So, it's a very common engine. And for all the integrations in Bootique, there are modules. So, like the first step is to add something, is to add a dependency with a proper module. And so we need Bootique Jersey. So all the standard modules that come with Bootique, they usually start with the name Boutique, and then you type the name of technology. And we also support Java EE or JavaX rather, and Jakarta versions of all the libraries in Boutique 3.0. In 4.0, we're gonna get rid of JavaX and just stay with Jakarta. So right now we're kind of providing this transition. So I added Jersey, and now we can actually write an endpoint. So it's going to be a simple thing, just hello API, so just hello world thing. And here we're going to see the first annotation. But this annotation is not ours. It's coming from Jersey, and Boutique is like really agnostic to like what the framework that it integrates does. It can do whatever it wants, and of course, with when we're writing REST endpoints, we want to use this JAX-RS annotations. It's fine. This is limited to the REST endpoints. So I'm going to write this get method, another annotation here, and just to be a good REST citizen, let's also do a produces annotation and set up the media type. So we have this, and of course, the body of the method is going to be simple and primitive. Okay, can we run the application and see what happens? We can if Zoom goes away. Okay, here we go. So I ran the same application, the same main method, and it printed help again. But in addition to all those commands, another command just appeared there. So there's a server command, and how did it get there, and where did it come from? Jersey module itself depends on another module called Jetty module. So essentially, we're using Jetty as a web server, and in Boutique, modules can add commands to the runtime, and they will appear on the command line. So this is a feature. So it's not, you don't need to parse the command line and just assign actions to it. It's actually a feature of Boutique. So Jetty has a server command, and we probably want to use that when we start our application. So I'm going to modify this command and just add server or -s, apply, run. So now you see the application is running because it didn't die. It is still there, but we can't see anything because of the login errors. So we need to add another thing. So we need to add a login framework, and we're trying to be very unopinionated. So like we don't bundle, just a login engine. So by default, Boutique itself doesn't even use SLF. I think SLF is coming from Jetty. But the real login provider that we provide is Logback. So you're probably familiar with it. It's used by Spring also. But you can just as easily write the same similar module, for instance, for Log4j or something like that. I can get rid of this guy. Then I can restart the application. Okay, so now the output is different. It's on Okay, let's do that. Happens on mouse over.
Where is it?
No, it happens on mouse over, I think, or something like, or maybe, oh, okay, on mouse over here. Thank you. So here we actually have a Jetty startup sequence. You see the startup time wasn't that bad, 170 milliseconds. And we have this URL that we can actually click and see it in the browser. So the good news is that the Jetty server is running, and we can actually access it by the port. The bad news is that our Hello World endpoint is not working. And the reason for that, and this comes to like slow startup times topic and everything else about Boutique. So in Boutique, we are making certain things more explicit and more code-based instead of just scanning the class path for like, okay, so what's in my application, and let's activate everything that I find. So here we need to kind of link our endpoint to Jersey. And how do we do that? So finally, it's time to make our own application a module. So far, we use the modules that are coming from Boutique. Now let's make this main class a module. And for this, you don't use annotations. You just implement an interface. And the good thing about it is that you can actually, it tells you which methods you need in the interface. And here's this configure method. And it takes a binder. I don't know, maybe some people worked with Google Juice in the past, so it's the same idea. It's kind of like an entry into your dependency injection environment. So binder just helps to declare some services, and then they become injectable everywhere else, or just exist essentially. So what we want to do here, we want to link our endpoint with Jersey. In Boutique, I think if you understand the thing about modules, it's going to be easy to discover what APIs exist and how to do certain things without even going to documentation. So since we're working with a Jersey module, there's a class called Jersey module coming from Jersey module jar, and looking at its static methods, it has a method extend binder. I'm passing binder there, and now we have a whole bunch of methods. So essentially, modules have their own APIs, and they interact with each other through the binders, through the dependency injection core. But essentially, they have the static APIs that tell you how you can do something with this module. And here we would like to add a resource. So resources is the endpoint. So we're gonna add this guy. I'm gonna restart it again and reload the browser, and you see nothing happens again. So one last thing here. Remember this autoload modules method here. So some modules are autoloadable. By default, they are not. Again, we're trying not to sort of like stick like unexpected things in your environment. So and also we're trying not to scan the class path for all the annotations, every single class that you have in your application, on startup. So we want fast startups. So we need to make this module autoloadable explicitly. And how we do it, we're using a very standard mechanism in Java. There's a service loader that exists in a standard JDK. It's not an extension or anything in the library. So, and the service loader is, of course, used by Jakarta EE to bootstrap services. And I know, like regular Java developers, they may not know about it, but it exists in Java, and it's a very standard thing, actually. And what it requires is a little file that just kind of helps it to find objects of a certain type, objects that implement a certain interface. And the location of that is standardized, so it's meta inf services. So that's the location of the descriptor file, and the name of the file should match the name of the interface that we're trying to load. So here it will be IO Boutique BQ module, and again, it's a standard JDK service loader that does that. And here in this file, I need to specify the name of the class. And of course, you probably use Java packages, of course. Let me actually move everything to a package. And in this guy, let's do demo main. So I just declared that this main class is a module. And I just told Bootique that, to load it when auto-loaded modules are loaded. So now when I click run, and I come here, finally we have a result. Again, I showed like a lot of steps, but it's really not that much code. So this is a whole module code. This main method, so that's the linkage, and this little one file. So I think this file is the only kind of like boilerplate that needs to happen for the module to become usable and discovered by Bootique. So now we have a web service. It's very simple, and we already seen some module behavior here. I want to change from modules like to the next topic is configuration. So how do we pass configuration to a Bootique application? Because that's important, because you integrate all these different modules coming from everywhere. Every one of them has their own configuration format, their own files, like some assumptions where they're located. We don't want that. We want like a single configuration system. And in Bootique, you would we will talk about like options where configuration can come from, but I just want to show you how it works in one example. The next step we want to add here is security. So let's make this silly hello world endpoint protected with login and password. And there are different libraries for security. In Bootique, we integrate a library called Apache Shiro. By the way, we thought about integrating Spring security because it's actually separate from everything else in Spring. So it's totally doable. It's just that Shiro kind of suits everyone's needs so far. So with Shiro, we also have a bunch of options: Jakarta, non-Jakarta, and we have like a Shiro that's not web related, and we have a Shiro that's kind of has stuff for web applications. So we're going to use that one and Jakarta and the Jakarta flavor. So now we added Shiro, and now we need to configure it. For this, I will create, it's one of the ways to create configuration is a YAML file. Remember when we saw help in the beginning, when we printed help, one of the flags was -c, so it could take configuration. I'm creating this config, and actually, just to save some typing in the YAML like weirdness, I'm going to copy paste it from here, but I'm going to explain what it means and where it came from. So there are two configuration options. The first one is for the Shiro kind of backend, not web related. It's where the user is coming from, and this can be, of course, anything. It can be like arbitrarily complex realm. So here it's right. We put the user right in the YAML. So the user is admin, password is secret. This is the user role, and this is how the role resolves to permissions. So essentially, the first section is about users, roles, and permissions. And the second section is like which URLs are protected by which permissions and like so essentially, this is Shiro syntax. This comes from Shiro documentation. And so it's just a list of filters that apply to this URL. And the first one is a basic authentication. The second is permission check. And we check it for this hello permission. So it begs the question, where I copied it from some file. So how did I come up with the structure? And more importantly, if somebody tries Bootique and they want to write this configuration, where do they get it? And we're trying to make it kind of discoverable. So we're trying to make it so that you can look at the application and figure out at least, I don't know, 80%, 90% of the configuration. And there was this one command that we've seen before, but we haven't seen how it works. This -H. So if I run the application instead of server, I do this -H, and I run it. What I'm getting is a JSON. So essentially, it's a template for configuration of every single module. First of all, it lists the module, so like we finally can see what modules are in our application. So here's our own. And then you can see like configuration that belongs to different modules. So we have Jersey module with documentation, Jetty module, lots of configuration there because you can configure connectors, SSL, and whatnot. This is logback, also lots of configuration because you can log to many different places. And finally, in the bottom, we have our Shiro stuff. So this is our Shiro realms. So you can actually like copy paste this piece, and this is how you start your configuration for the application. Start writing this configuration, and here is the Shiro web stuff, and here is the URL, and it says string, and then it explains what the string means. So the strings mean, and refers to Shiro documentation. So all the filter names are coming from Shiro. So essentially, each application is self-describing to an extent. Of course, there's no magic there. It's all the things are either Java structures that are presented as JSON and some documentation annotations. So we're using annotations for the way God intended them to be used, for like documentation. Essentially, you can understand what the configuration should be. Okay, so let's add this configuration to our server startup via config option. And let's restart the app. And you can already see the Shiro is doing something there on Jetty startup. It's adding some stuff to Jetty. And now when I reload this guy, it's asking me for username and password. And of course, if I type it incorrectly, it's going to ask again. If I type it correctly, I hope I typed it correctly. Okay, so it works, and we can spice it up a little bit and just add some information from Shiro into the prompt. So like here, instead of hello world, we can say string format. And we could have injected some services. I don't have time to show all the details of injection. I'll talk about it a little bit about it on the slides. But here I'm going to use a static method from Shiro. So essentially, it binds via its filters to the request thread. It binds the user principal, essentially. So you can use it in a static with a static call without injection. So I can do this get subject and get principal. So essentially, security utils get subject gives you all the information about the logged in user. Okay, let me restart the guy, and since I'm already logged in, it immediately prints like hello admin. So essentially, this the security information. Okay, so one last thing in the demo, we have it's not a real application, but it has all the kind of parts and like of a real application. It has REST services, it has modules, it has security. Let's add another piece. Let's add one final piece, which is tests. And here we would like to, I guess unit tests are not good enough these days, so we would like to have integration tests. We would like to actually this application to be started within JUnit and then interact with it through a port, and then make some assertions about the responses. And of course, in this application, there's no database, but like in a real one, there'd be like the database driven by test containers and so on and so forth. So here we're gonna just write okay, demo hello API. Oh, gotta be hello API test, I suppose. And let's also add some dependencies. We can add JUnit 5 directly, but I will add also some boutique extensions to JUnit 5 that will make all the tests smooth and actually behave the way a command line would behave. Just a regular application that runs, not in a test, but is run by a user. So for this, we need something. There are a few JUnit 5 integrations across Boutique, like different modules, like database-related modules. They have their own integrations. So here we need the one for Jetty. So I'm gonna use this Jetty Jakarta JUnit. I know it's a little long, and hopefully in Boutique 4.0, when we get rid of JavaX, we will strip the Jakarta suffixes, and there will be like fewer choices. And of course, we want it to be scope test. So this will bring JUnit 5 dependencies plus lots of the extensions. So here I can write a test, say hello, and I can immediately annotate it with JUnit 5 test annotation. And here, here we'll start to see Boutique annotations because we didn't decide not to rewrite JUnit 5. So this was like out of the question. and Unit 5 operates on annotation. So essentially, if you want something to happen, before a test or before like a bunch of tests, you need to create a hook that will tell Unit 5 to call some of your code. And so this is what we did. So there are 3 Bootique-related test annotations that are only used in tests: BQ test, BQ app, and BQ test tool. I'm going to demonstrate the first 2. So the first one, just you need to put it on top of a test if there is some Bootique lifecycle involved. And now, unlike SpringBoot, where you actually use annotations to add some behavior to a test, we're not adding behavior to a test. We just like this annotation is just a glue between Bootique and JUnit, nothing else. So all the behavior happens in the objects, and the main object in Bootique application is BQ runtime. That's the application object that holds all other objects. So here I'm just creating this object BQ runtime, and the way to create it is to actually go to your main method and kind of copy this with some changes, but so the arguments are going to be server. So essentially, the logic within the test is the same as the logic of a person who is running the application. So we're adding the same command line flags: config YAML. Autoload modules is good, but instead of exec and exit, we don't want to execute. We want JUnit to execute it when it's ready. So essentially, I'm removing these 2, and I'm calling create runtime method. So it will create the application object, but will not execute anything. It will just sit there. But this also needs to be annotated with BQ app, because that's our application. So it's kind of easy to remember. And we can actually run it now, even though we don't have any test code, but we already have some life cycle. We have some failures, and it failed to start because port 8080 is taken by the other applications that I was just showing, right? So this is the thing that you need to avoid in your unit tests, essentially using the same port that somebody else may be using. And how do you know what port other people are using? You don't. So instead, we have like a little extension that allows you to bind to like a random port when you run a test, and then like obtain a client, an HTTP client to talk to that port. And this comes from this Bootique Jetty Jakarta JUnit 5 module. It's like nicely named. And it's called Jetty Tester. Oops, Jetty Tester create. So I'm just creating it with code. There's no annotation here. Some of these testers are annotated with a third annotation called BQ test tool, but Jetty doesn't have any, this one doesn't have any specific lifecycle, so it's not required. And here we're gonna take our standard application and just add just a little bit of test-specific stuff in it. And extensions in Bootique are done by modules, so that's going to be a module also. And this Jetty tester is going to generate this module. It's called module replacing connectors, meaning that it will create a Jetty connector on the port that's actually available in our environment. So, and you don't need to think about it, and you can just write it and forget about it. Now I'm actually gonna steal some code from here just to avoid typing, but I will explain again what it does. Okay, so here we are taking our Jetty tester. We are calling get target. Target creates a client, and target we are using the terminology from JAX-RS, actually from Jersey, because Jersey is not just a web services framework; it's also a client. So it has both server and client, and we're using the client here to connect to whatever Jetty services. And target is already a Jersey object. It's this web target object that it's specified in the JAX-RS specification. So from there, it's just pure JAX-RS. So you call a request, you set in a header, and header is our authentication. This is admin secret. So we encode it for base 64, and we do get. And Jetty tester will also help us to check the results. So you can do assert. There are some static methods that you can do assert OK, and you can do assert content hello admin. So let's run this again and see if it works this time. So you see it works this time, and like you can see how the port, this is a port that was used, so it just assigned a random available port that's not taken. And in the test itself, there's a real web request to the port that was executed, and then we assert the response. So it's a really easy way to create an integration test of a real application. And the interesting part here, to me at least, is that our application is an object. So we're testing an object. So it's just like a test should be written. So you take an object and then you just interact with this object. So our app is an object here, and we can write this methods. And of course, if you have database, if you have Kafka, if you have RabbitMQ or something, it doesn't change anything. You will have the same, maybe like similar scenes for like to start Kafka with test containers and then connect connect to the runtime so that it knows where the connection is. Okay, so this is a demo. Let's go back to the slides. So let's recap real quick. So what does Bootique do? Why do you even need Bootique? Can you write, you have a main method, you can write the same application without Bootique. Of course you can, but it helps you a lot. And what it does is, at the first stage, it loads this object creation recipes from modules, and we'll see how modules are structured in a more general case in a moment. Then it loads configuration also from multiple sources. We'll see what those sources are. Then it creates objects in a shared space, which is this BQ runtime that we saw in the test. So it just like creates, I don't know, like Jetty server. It creates some Jersey stuff, like glues them all together, and then it and gives you a BQ runtime object, which holds all those things in the applications that came from modules. And then it executes a command, and we saw the command. So dash server will actually start that Jetty server and listen on the port, listen for requests. And this is it. I mean, from there, it's all the frameworks, is Jetty, Jersey, and so on. So Bootique is just like helps you to glue things together and in a consistent manner, pass the configuration, and then let the application do its thing. I like this, but it's like totally, you can't measure like, how much magic you have in your application. But I like to think that we have like 70% less magic than the alternatives, and at the expense of a very little extra boilerplate, like that meta-inf services file, essentially. We still have 30% of magic left because we kind of decided that without dependency injection, you can try complex applications. So in theory you can, but in practice it's just like wiring things together is too complex. So the 30% remaining magic is essentially dependency injection, and some of it is tests. So this is what I haven't you haven't seen in the modules yet. So like if you want to declare a service from scratch in a module, and this is actually examples from the Jetty module. So this is like really, this is from Bootique standard modules. You would write this kind of provides methods, and they're magical in the sense that they require the annotation provides, because otherwise they will not be processed. But also because they're not called from anywhere. So if you do a search of like who's calling this method, nobody's calling this method. So it's just so this is where it's a trade-off where we actually came back to, okay, so we still have to have some kind of declarative behavior for Bootique to actually come in and check the annotations and do something about them. The difference, of course, is that the modules themselves are very easy to find due to this meta-inf services declaration. So essentially, we're not scanning everything. We're only scanning like those like, I don't know, 5, 6 classes, or 50. I don't know, depending on how many modules you have. Another cool thing about modules is extension API. It's a static API where you pass a binder, and then you can actually interact with the module. And usually it's like this container modules, like web server, like you put servlets in that, or filters, or like Jersey where you put endpoints there, or WebSockets. It's the same thing. Like you put like WebSocket endpoints in there. So all this API is discoverable. So you can always, like, if you just start with the general concept, okay, I'm writing a Jersey app, and then you can go and like, okay, I can add a feature. So what's the feature? Let's go check Jersey documentation. It will explain you what the feature is. Um, Modular discovery, I already mentioned it multiple times. So essentially, we are avoiding the performance penalty of a class path scan. So we are essentially working these little descriptors. They are discovered on the class path. There are going to be multiple of them, and they're combined together. And all those modules are loaded. There's a question.
How come you didn't have to register the logback module?
Because a logback module, it's a jar, right? So module is just a jar, really, and inside the jar there was this file as well. So each one of the standard Bootique modules, they are auto-loadable. They have this file in them. Yeah, and so essentially this is how like server command got in there and everything else. So this is what we have like in the Bootique ecosystem. So these are the things that you can just take and use it without writing any code of your own. So we integrate with Amazon Web Services with S3, by the way, and also version 1 SDK and version 2 SDKs. But yeah, don't use version 1, of course. All of the open source projects that I mentioned on the second slide, they're here, of course, Cayenne and Grest, and there's JDBC, the data source management, JCache. There are 2 frameworks for database migrations, Flyway and Liquibase. There's RabbitMQ, Kafka, Mongo, Shiro, you name it. A couple of things that we provided ourselves, like I mentioned, Boutique jobs, because like we didn't find like a good lightweight scheduler for jobs. It's actually using Spring Schedule internally. We have like a little very simple MVC framework. But if you want, for instance, like there's no Hibernate here, for instance. It's like because we are using Cayenne instead of Hibernate, and but if you need Hibernate, and many people do, of course, you can write your own module, and it'll probably take you, I don't know, like anywhere from 30 minutes to a couple of hours to like get something running, because it's really not that hard, because the main code is, all the logic is in Hibernate itself, and this is just about wiring it into the Boutique application. Another thing that I really love about Boutique applications is CLI, and again, I mentioned it a couple of times. So POSIX CLI is nice by itself, but it's also very different compared to how other people are doing it. So usually, like in the typical Java applications, that is a CLI. First of all, there's like very little CLI culture in Java in general, but like essentially, people would take a library that parses the command line and then into some map, and then take this map and decide what to do with it. So in Boutique, it's more direct. There's a cause and effect. So essentially, like if you have a module, and in that module you write this command class, so there's an interface for command, and you write a command. It's a certain interface it's well defined, and then you use this extension API to contribute it to the core module. You will see this command in help immediately. So essentially, there's a when you specify a command like server, it's a cause, and you will have an effect of calling a class. So you don't need to do a dispatch yourself. So essentially, the dispatch mechanism is in the core of the framework. And of course, there's helpful for the commands that helps everyone to figure out what the app can do. Configuration. So we've seen how to do configuration via YAML file. But there are multiple levels. Of course, we don't want to limit the users how you can configure your app. So the first one, you actually do it in the code. So you can just reference a class path resource. It's not unlike Spring. They're doing something similar. And I guess the point here is that most of the configuration is just very technical to the end user. It's just about like wiring things together. And you don't want to expose it and you want to have like a template for your application, like default values. So this is what you hard code those default values by adding the YAML to class path and editing the code. Then you can pass it through this config flag. Then you can also pass it through properties, but we kind of discourage doing that because it just reminds of the bad old days of Java when all the configuration was done via like properties on the command line. But it's also an option. And then there's environment variables, also an interesting one, because first of all, it's very important in modern deployment environments. So everything Docker or Kubernetes related or whatever, or Amazon related, it's all environment variables. So essentially, it's nothing else. It's not files. It's actually like a var. It's a shell var. But the shell vars, they're not arbitrary. So they actually declared explicitly in Bootique applications. That's another configuration that you can do on the core module. So there's an extension of the core module where you say, I want this var to correspond to ABC property path. And what it does, first of all, it creates some sanity, like in general, in the application, but more specifically, it creates help for this variable. So when these variables will be in help, and your DevOps people or whoever like trying to operationalize your application and like wrap it in Docker or whatever, they will see what variables the application recognizes. And the final one, the little icon in the bottom, is it's Amazon Secrets Manager, so you can actually load configuration from Secrets Manager on Amazon, but potentially from other secret managers as well. So in the middle of that diagram is a JSON tree. So all this configuration is kind of merged together, so overlaid, so from in certain order, one after another, and then we create a single JSON tree internally in the application. Again, you can merge configuration, but you cannot script it. You cannot put like a $sign and a variable inside the YAML. So it's not going to work because, and that's by design. Like some people ask for it because they want it. They like, you know, this like super dynamic thing. But we decided it's, first of all, it's really unneeded if you think about it. So you can express everything like in terms of this. And second, it doesn't create the second level of interaction that confuses people about like, you know, where did this configuration come from and like where did it go and like how did it actually connect to the final outcome. And on the right-hand side is an object tree. So essentially, I'll show you in a moment from this big configuration tree, like subtrees of that configuration, they actually map to objects. And here, for instance, here's an example how you do it in a module. So here, it's also an example from Jetty. Server factory is a class that we want to create and populate with configuration values. So we take this configuration factory, which is a boutique theme, which is a place where that JSON tree is stored, and we say that okay, so please take a prefix and like find a subtree at this prefix and apply this, create server factory and load its properties from the JSON. And of course, it's hierarchical, so you can have like the entire subtree of objects. And there's polymorphism, so you can have like subclasses and configuration and stuff like that. But the point here is like this, like for instance, that helps, that YAML helps that I showed, where configuration was actually printed as a YAML file. It all comes from the object structure. So we can look at the object and tell the user what the configuration should be because we know the object structure. And of course, with the help of some documentation annotations, we can provide some descriptions for what this or that property means. So configuration is, I think, it's both powerful, but it's not too powerful. And now, of course, we were talking about who is fast and who is slow. So this is performance numbers. So I have a couple of slides. There's 3 metrics here: startup time, jar size, and the memory use. So the first one is startup times, and this is done on a little older laptop, but it's still I think it applies on like any hardware. Really, these proportions, maybe not the absolute values. And for each one of the performance metrics, I'm comparing like an empty app, which is not even hello world. It's just like an app that just starts and dies. And a second one is a very simple kind of like hello world REST app, also from 0 to just a startup when it starts listening on the port. And the black bars are Boutique, and the green bars are SpringBoot, and of course the smaller bars are better. So like Boutique application on that hardware started in 160 milliseconds, and SpringBoot application started in 740 milliseconds. And this is an empty app that does nothing. So it still takes like almost a second to start it, like in in the Greenland. So and again, like, there's a reason for that, because Spring Boot applications, they're scanning annotations everywhere, so they need to understand what's in that app, and we don't. We just need to check for those meta-inf files essentially, and load the module. So instead of scanning, I don't know, thousands of classes or I don't know, hundreds, thousands, we're scanning like, I don't know, less than 10 maybe, or something like that. In an empty app, it's going to be like 1. And the same thing stands true for the REST app. So the proportion may be a little different, but the delta is still there. So much faster startup times if you don't need to do all the extra job and guess what the user was trying to say with their code. Jar size. So I don't know how many people care about jar sizes, but maybe sometimes you should, because it's both sort of it's your bandwidth. It's also like disk space, and people are saying that okay, disk space is almost free these days, but this is not what I'm hearing from my operations teams, where, like for instance, like running a Maven repository like Nexus, it's a difference between like upgrading the 1 terabyte disk to a 5 terabyte disk like once a year versus, I don't know, once every 3-4 years. That's actually a real story, because like, that's the system that, people, operations usually have to maintain as it grows, the repository. So again, an empty app in Bootique is 2.8 megabytes, and I think it's too much actually. Like, and we can do better. We have an idea how to like squeeze it even smaller. The Spring Boot app is 10 megabytes, like an empty app that does nothing. So, and this is just a philosophy essentially. Like, Spring Boot, they try to like pack as much as they can so that it's kind of all available out of the box, and we're trying to be like very nimble. So essentially, you only add things that you need. So it's like we're coming from different ends of the spectrum. And the same thing goes with the REST apps. There's also a big difference, even though I try to compare apples to apples. It's not necessarily apples to apples, because like this like Jersey versus Spring Web, there are 2 different things. But I think this difference is still like genuine. It's not because we use 2 different web frameworks. And finally, memory use. Again, the empty app. Like empty Spring app uses like 4 times more memory than an empty Boutique app, and the web app also like has a delta. So this is your Amazon bill essentially, because memory is directly proportional to how much you pay for your EC2 instances and stuff like that. Okay, but at the end of the day, again, like people are usually saying, okay, so it's just like, okay, so my CI/CD is a couple of seconds slower, or because the application starts slower, or I don't know, somebody needs a bigger disk to store my build artifacts. I don't care. So what people I think care about is like development time. So when your application starts like, I don't know, a couple of seconds slower than it should, that's the time that you're not getting back. So it's just like essentially you're waiting while it's restarting. So there's a presentation. We have Boutique is still on Twitter. We haven't registered on Blue Sky yet, even though I already did. And it's a well-supported project. It's been in production for years. It's we keep developing it. So we accept ideas. If you want, like to work on a new module together with us, always come, and like we can figure out how we can make a standard module, and like part of it supported by you, part by us, and stuff like that. So it's a community project, and it's really cool. And like everybody who's using them, I mean, who's using it, it's I think it has a great value. Thank you very much, and be happy to answer questions.
Back here.
Yeah, I have a quick question. I think it's you compare it with the Spring Boot. It is known for being heavy in general.
Yeah.
But at the same time, it is known for being popular. So probably you choose the second reasoning. But anyway, there are different ones like a Micronaut, and there seems to be a trend towards these more lightweight ones, because Spring Boot is becoming problematic for especially like Lambda functions and things which are up and down on the web, scaling and stuff. So it doesn't fit very naturally. It comes from the word when you were starting things and they were just running. So it didn't matter really how long it took to start it, you know. But now, as you have lambdas, this really
Yes.
matters, you know.
Yes.
So did you try to do a comparison with especially one called Micronaut?
Yeah, I know about Micronaut, but I haven't done any comparisons. I think like from what I'm seeing from like far away, I would say I think we're not trying to be like weird essentially. So we're just trying to, like everything in Boutique is like very simple and transparent. So that's a philosophy. Again, like I can't compare unfortunately feature for feature right now. And yeah, that's a valid question. We should probably do this comparison. Yeah. And I agree about lambdas because and I think right now people create a workaround for lambdas is using Grail VM to compile everything to native binary, but you cannot do it in development. It's very slow.
Hey, I think another interesting point of comparison would be to look at side-by-side stack traces. If you get like an error,
Right.
and then see what it's like for SpringBoot versus Boutique, because Spring is known generally for massive stack traces.
Yeah, it's a good point. Yes, it's something I suspect where this comparison how this comparison will look like. So I have suspicion.
Yeah, you seems to be against annotations, and I think you're right. It's hard to find out what actually is happening in an application, but I just have a question because there seems to be trends in the software development, and at some point it was annotations, and everyone wanted to go with
Yes.
annotations, and it was not very clear always what they do, these annotations, because they were runtime. You couldn't predict what's going to happen really.
Yeah.
So now it was always not very natural to debug even applications that are using annotations. So why nobody ever said anything? Just everyone went for annotations. Is this one of these crazy ideas everyone decided, let's follow it?
Yeah, but it also seems like it's a good question. Like I don't know. Like I've never been on that bandwagon with annotations because like even if you compare Cayenne, like the ORMs that I'm the author of, and Hibernate that we kind of like we were developing in parallel. Like we started probably the same year. Cayenne doesn't have annotations at all. Like you were doing persistence without annotations. So essentially, and Hibernate is, of course, it's all about you can do it without annotations, but like nobody does. Everybody uses annotations. So like it's not clear to me. I can't comment why people like annotations. I can comment why I don't like.
One good question. So with Spring Boot, if you have like a Kubernetes pod and you send a shutdown, you get a SIG term, you could institute like a graceful shutdown. You could register handlers to save state, and then you could execute like a termination grace period to like kill the pod. Is a similar functionality here, or do you have to like write the shutdown handlers yourself?
Oh, well, I mean, Kubernetes, like, and pods and everything. So, like, it's another layer, right? So essentially, so there has to be something in the application, and boutique applications are, it's just, first of all, yeah, I mean, there are shutdown hooks that you can actually program to do certain things, and most modules that care to shut something down, like, database connections or Kafka or whatever, they're using those hooks. So essentially, once you add a module, all those hooks are already pre-installed for you. Yeah, so and you can write your own if you have something custom. So and yeah, so boutique applications, they're trying to behave just like a Unix process essentially from all angles essentially.
Question. Get the slide. Is there a Spark module available for the boutique?
Is there a what?
Spark.
Spark? No, there's no Spark module, but essentially, like, how would you want to use Spark with Boutique? Because Spark is an engine itself, right? So essentially, so everything, like, you deploy code inside Spark, or so what scenario you're talking about? Like writing a Spark job with Boutique?
Yeah, like there are so many dependencies which I struggle with in Spark. I was thinking that can this
Yeah, I mean,
simplify those.
but the potentially it can be like we never looked into that, but like again, if you just you know show up in our forums and like propose a scenario, we'll definitely be happy to discuss.
Sure, thank you.
Yeah.
So as you mentioned, Spring is popular. How popular is Boutique today?
Much less than Spring.
Yeah. But is there anyone?
And we are kind of like, you know, we're fighting an uphill battle. Like for instance, like New York Times here in New York, right? So they started writing applications in Boutique, and I think everybody in the dev team was happy. But then, you know, they had a few like changes of management, and at some point they were like, okay, so we're standardizing on Spring Boot, we don't care. So essentially, one group here like using Boutique, like get out, you know. So like we are facing an uphill battle, yes. So and especially because like Spring Boot is so popular, and like you know there are probably reasons for that. I don't understand them, but I admit them.
You mean there's politics in big companies?
How could that be?
Any other questions? Okay, thank you very much, Andrus.
Thank you.
So who were the people that do not have an IntelliJ license? Well, now there's more than 5 now. So raise your hand. I want to see if is there 5 or there's more than 5. Okay. Who really needs it? Out of those, I can give away 5. Actually, I can give away 6.
Thank you.
No, nobody really needs it. All right. So I'll tell you what, just if you really need it, send an email to info@javasig.com. And if we run out of licenses, you'll get it next month. Okay. So I want to thank Bank of New York Mellon for hosting us. Thank you, Bank of New York Mellon. Thank you, Oracle, for the pizza. Please take a soda home. Please take a soda home. Thank you to JetBrains for licenses. What else? Have a great holiday. Okay.
Yeah.